Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem, and here we have n plus 200 and its whole cubed equals to 22 minus n, and we will solve this problem for the real values of n. So now we will just solve this problem for the real value of n. So the very first thing we are going to do is here first we will just take here y equals to n plus 200, and now we can just simplify this given equation. So in order to make some simplifications here, I can just take y equals n plus 200. So our given expression will becomes in the form of y cubed equals to here you remember one thing is that when we take y equals to n plus 200, then here you will find the value of n, and we move this 200 in the left hand side, then you have y minus 200 equals to n. So now we put both of the values, the value of y and the value of n, in this equation, so that the left hand side will becomes y cube, and when we put the value of n in the right hand side, then it will becomes 22 minus y minus 200. Okay, so now we will make a little bit simplifications here, and the very first thing we are going to do is here first we multiply this minus sign on both of the terms, and you get 22 minus y plus 200. And in the next step we will move all the terms in the right hand side to the left hand side, so that its left hand side will be rewritten as y cubed, and when we move this minus y in the left hand side, then you get plus y, and here you have 22 plus 200, and it will be equals to uh, 222. And now here you focus on the right hand side, and we have in the right hand side is 222. So we will write this 222 as 37 multiplied by 6, and now we can write this 37 as 36 plus 1 and multiplied by 6. So here we will write this 36 as 6 squared plus 1 multiplied by 6, and now we multiply this 6 on both of the terms, and then you will get here 6 cubed plus 6. So in the next step we will just replace this 222 by 6 cubed plus 6, so that our given expression will becomes in the form of y cubed plus y equals to, here we move this 222 by 6 cubed plus 6, so it will becomes 6 cubed plus 6. So now we move all the terms in the right hand side to the left hand side, so that we will write it as y cubed minus 6 cubed and plus y, and we can write this minus 6, and this whole equation equals to 0. So here we have two factors, these two factors. So now we will focus on the first factor, and you see that we have a cubed minus b cubed. So now we will use here the nice cubic formula, and you know that if we have a cubed minus b cubed, it is equals to a minus b times of a squared plus ab plus b squared. So now we will use here this nice formula on the first term. Our first term will be rewritten as uh, here you have y cubed minus 6 cubed, so we write y minus 6 times of y squared plus 6y plus 6 squared. We will use this cubic formula here, and now you write this y minus 6 as it is, and this whole equation equals to 0. And now in the next step, you will see here we have y minus 6 it is present on both of the terms, so that we will take common here y minus 6 on both of the terms. So we write it as y minus 6 times of y squared plus 6y plus you have 6 squared becomes 36, and we take common y minus 6 here, then you get plus 1, and this whole equation equals to 0. So now we will take a little bit simplifications here, and we get y minus 6 times of y squared plus 6y plus 37, and this whole equation equals to 0. So now here we have two cases. The first case is we take y minus 6 equals to 0, and the other case is we take y squared plus 6y plus 37 equals to 0. So in the first case you will get the value of y equals to 6, and now we can find other real roots from this quadratic equation. So in order to find the other real roots, we will first solve this nice quadratic equation. So here first I can check this quadratic equation has real roots or not by using the discriminant formula. So that here we have a equals to 1, b equals to 6, c equals to 37, and you know that the discriminant formula is delta equals to b squared minus 4 times of ac. So now I can a little bit explain this discriminant formula, and you know that if the value of this delta is less than 0, then we say that this quadratic equation has no real root. And similarly, if this quadratic, if this delta will becomes greater than 0, then we can say that it has two real root. And similarly, if the value of this delta will becomes equals to 0, then we say that this quadratic equation has only one real root. So now in the next step, we will check the behavior of this delta by putting the values of a, b and c here. So you get this delta equals to b square, and the value of b is 6, so it will becomes 6 square minus 4 times of a is 1 and c is 37. So you get here 36 minus 4 times of 37 equals to 148, and when we subtract 36 by 148, then you will get here minus 112, and you see that it is less than 0. So if our delta is less than 0, we can say that it has no real root. So here you can just write it has no real root. So if it has no real roots, then we will reject it this case, and we can just proceed here this case only. So in this case we have y equals to 6, and in the start of the problem we will take here this y equals to n plus 200. So now we will back substitute the value of y, and it will becomes n plus 200 equals to 6, and we move this 200 in the right hand side, and you get 6 minus 200. So finally you will get the value of n will be equals to minus 194. So this is the our final answer of this problem, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.